What's up, guys? What's up? Look what I got here. I got a battery hookup. Battery hookup. So if you want to build your own batteries, go to Battery Hookup. That's why I've been getting my batteries. What they are, they have a bunch of used batteries that come from. I blew this one up. I built this one before. This is the one I told you how to redo because I got swollen and I screwed it up. See that? So this in turn gave me the idea for the BMS, and this is the BMS. The BMS is a battery management system. I got one in over here. I don't have it taped up yet. And they're just, I don't know if you can read that. They allow a certain amount of voltage and amps and stuff, and it manages the battery. Like this is a 12 volt, 100 amp 4S. So 4S and P, the series stands for series, and parallel. So parallel would be like these. Each one of these, fully charged. I wrote this stuff down here. So each one of these fully charged is 4.2 charged, 2.8 dead. So if I get my meter, my trusty got you on the head, see if this works out. So I'm not dying over here. So if you guys don't get this for free over in Harbor Freight, or I think it's like $2, it doesn't have to be Harbor Freight. It could be anybody. Just as long as you get a voltage reading, right? You test it out. It's supposed to be 4.2, between 4.2 and 2.8 is dead. And you need a total of 12.6 volts, right? To make a battery. So on this side, this is the copper, so this is the negative. And then the silver is the positive. 4.3. 4.4, that's actually a little overcharged. And this one is the silver one. Silver and copper. 4.3. Oh wow, these are nicely charged. And then we go back over here, and it's copper negative, negative, and silver positive. Oh wow, these are nice. And 4.0. Wow, this is a fully charged battery. So this has 16 volts in it right now, fully charged. I think it's overcharged if it's swollen, because it's supposed to be 4.2. It's fully charged, and they got 4 point something here, 4.6. We got to make a 12 volt battery for my fridge, so the fridge works all the time. Because I got a camping fridge. We're just gonna make our own battery instead of buying batteries, because it's pretty expensive. And I think I did a good decision on doing this, going to these people to battery hookup, because these are special batteries. These are lithium ion batteries, phosphate batteries, and they're high amperage. Each one of these, because there's 4 of them in there, Jesus. So this is 20, this is 20, this is 20, this is 20. So it's 80 amps here. But if you have it in series, it's going to stay only with the 20 amps. But if you go in parallel, you're multiplying the amps. So we're going to make a 12 volt 40 amp system. So you got to go negative, positive, negative, positive. So I had it here where I had 2 of these together, which was still 3 volts, right? So 3, 3, 3 makes 12 volts, or 9 volts, I'm sorry. 4, 4, 4 makes 12 volts. So these 2, the bottom one I'm gonna put on top, so I have the deep cycle, the deep ones on top. So that's what I want. Let the bottom end be kind of weak, it doesn't matter. But when it gets that inertia, that full charge, boom. So now the way this works is these 2 are gonna be 1, right? They're both gonna be 1. They're gonna be positive, and it's gonna take the most draw out of that. And then positive, negative. Now this becomes, so this is 4 volt, 8 volt, 12 volt. So once you connect these 3 in series, like a S, then you'll have 12 volts. So if I read this one, you have the meter in there. Copper on this side, copper is a negative, positive, 4.3. So now if I jump, and the other one is going to be the same thing, 4.3. 4.8, wow. Oh, that one's overcharged. Oh, I wasn't even touching it. 4.7. Jesus Christ, is it going up right now without doing anything? 4.5. These things are charged to the max. Oh. 4.5. They're all at 4.5. So 4.5. That's 16 volts. That's crazy. This is fully charged. So I didn't think it would get the charge. Jesus Christ. So 4.5 times 3 is 13.5 volts. I forgot I was counting 4, because if I went 4, it'll be 18 volts. So we'll only put it in series, right? I hope this helps get everybody out. So here, these are the LG chimes. They have that number. I don't know if you guys can see that UPC code if you guys want to look that up. So there's 4 cells in here, and each one has 15 amps. So if you look at this, there's 2 cells in there. There's 2 packets. They're like this, simple packets, pouch batteries. So it's 15, 15, 15, and 15, making it 30, making it 60. But they lost a lot of their life, so they only have 40 amps instead of 60 amps, which is still good if you're just running a fridge for a weekend. All right, so let's put it together. We got to go positive, positive, right? And we got to put the BMS in there, and then charger. So what happens when everything's working. So we're gonna go to the negative. Well, first thing first, let's make this 1 cell so we have an understanding of that. Alright, so here I just cut a couple of brackets right here. And these two are going to go together. That's it. And this is going to be 1 cell. There's a bunch of guys. I got into this because I saw a couple of guys getting into it. This guy, Jehu, he went to Puerto Rico from California, and he helped out a bunch of people. Then after that, I was kind of fascinated, right? Well, this has the numbers on it. So this is going to be 1 cell. So we're going to join this together. So this is just going to be, so I'm multiplying the amps here. So instead of it being 4, it's going to be, this guy is persistent, Jesus Christ. I'm sorry, guys. He won't stop. So I want to get to 80 amps. So if each one of these are 40 amps, I got to multiply 2 of them to get to 80. Because that fridge uses about 5 amps. 10 hours is 50 amps. And 12 hours, and you just go up from there. So at least I have 80 amps. It would run for 10 hours. And I'm assuming that we got sun for so much time, for 8 hours at least, that every day I'll be fine. I'm sure it'll run for a couple of days on this, 3-4 days. Okay, so let me connect these. I'm sorry. All right, so we're just connecting these right here. Boom, boom, and we're just making 1 big cell on this one. So this is gonna stay 4.2, and it gives me a leg to jump off too over here too. That's pretty cool. So we're going to join that, right? I don't have to over tighten it because I'm going to take them off again in a minute because I got to. And that was just a bracket that I cut to make it work because it just fit perfectly in there. I brought several different types of batteries, some headways. These right here, the SPIMOMs. Each one of these cells are 8 amps. And I got the TV out, and then we're gonna plug this up and see if we can get it running. You know, just for a couple minutes, not too long. I don't have to make that too tight. So now, if we measure this, this is one cell. We're still gonna say 4 point whatever. Jeez. So this is the copper side. The copper side is the negative side. Negative, positive, 4.2. I go to the bottom of that, 4.2. It doesn't matter. Now it's one big 4.2 cell, right? So now we got another 4.2 right here. So this is negative. We're going to positive. Negative to positive. Boom. I think that'll work. Negative to positive. Hey, get out of here. Oh, it's in my lap. Going crazy, people, going crazy. Hope you guys can see this. And join that there. Alright. Because that's negative. You see the copper, negative, positive. And this in here. Hey, little bird. Hey, little guy. How you doing? I put food up there and the hide up in there. So, okay. So then let's join this one. And this is negative. No. I'll join this. Oh, see that? It's already, the voltage is already jumping up. Once you cross the other side, oh, I'm doing something wrong. Oh, that's right, that's right. Fuck. The cell is negative, positive. Negative, positive. The cell is one side. I screwed up. I think I screwed this up bad. So now, with my meter, if you still smell it smoking, well, you're obviously not gonna smell it smoking. I fried this. I fried it. All right, let's see what we got here. So this is the negative side, the copper side, negative. Oh, that thing is. All right, let's go here and here. 4.3. It's still good. All right, so not bad. So now if I go down here, 4.3. I'll fry that one. Right, this is supposed to be negative. Negative 4.3. Oh, I screwed up bad. Or is it supposed to be? Oh, it's supposed to be negative, and this is the positive now. This will make it 8. So positive on this side, right? Negative on this side. 4.3. Negative 4.3. So I screwed this up bad. Let's see what's going on here. Maybe because this is not connected. Well, guys, don't do that. Oh, see that fried part right there? Alright. Let's see what happens here. So that middle one is supposed to be the bridge. I screwed up. So positive, 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 negative. Negative 4.3, sorry. Positive, positive. 4.3, one big cell. Alright. So if I move all the way to here, 4.3, and here, 4.3. What's going on here? So I got the pot. Oh, this is the negative. Negative here. Then, oh, that's why. I'm supposed to be positive here. Alright, positive here. And negative here. Negative here. 4.3. Yeah, I shorted one of these out real good. 4.3. Why didn't it go up? Negative. Nothing. Negative. I don't know what I did wrong here. But I know what I did wrong. I shorted it out. Alright, that one. So it's supposed to be negative, positive. Don't connect that one. Connect this side to this one over here. And that's the bridge. I thought these two had to be connected. Guess I was wrong. Live and learn. So I probably fry this thing and it's not going to work now. Probably, I did fry it. I shorted that sucker out. Probably killed one of the cells. I won't get 12 volts probably. So the positive side here should be to the positive side here should be the negative side here. Then the negative side there, so the positive side here goes to the negative side here. Okay, yeah, alright. So now I should get 12 volts. Well, I fried one, so I'm not going to get 12 volts. I got positive here and negative here. Oh, I got 12 point, negative 12 point something. So I got it backwards. So this is positive. This is our positive lead, and this is our negative lead. Yeah, 12.6. There you go, guys. We got 12.6. You see that? So this is our positive lead right here. This is the positive, and that's the negative. So I got to go all the way to the bottom of the bank down here to get to the negative, and then I get 12.5. So now, in theory, this is a 12 volt battery, so I could turn on that TV, right? So, that's perfect. Yeah, just some jumper cables so you guys see that it's legit, right? Okay, this is not the best way to do this, especially that's metal. Let me get a. Oh, this is basically. So this is going to go to the battery. Positive. We said this is our positive right here, boom, and this is our negative down here. Shit. Okay, we can turn this around. Make that hang off the bottom, right? So again, this is our positive up here. Boom. That's a negative over there. And then we got our negative here. So we can push this off to the side. Like that. Get a piece of it. Alright. We get a piece of it. Up. On a big piece. There we go. I think we got a big piece of it. So that should give us 12 volts. And when we connect this to that, we should be able to turn on the TV and watch some TV. And here, connect to this. Yeah, we got a spark there, so we're good. There we go. Just kind of want to sit in right. Boom. Boom. We got light and power. It's gonna work. There's a remote. Need some water. Oh, I gotta turn this thing on. From 1000 to 1008. It kind of clears this off. 12.3 volts is reading, so let's power this up. There we go. $450. Oh! We got TV in the desert! From battery hookup, guys. They didn't send me this.
More storage capacity and overall power. In fact, the Power Cell has one of the largest storage capacities on the market today.
As you see, the bat.
Power Cell is customizable, allowing you to expand your solar storage capacity by a 10-year limited warranty.
CBS.
You get the sensitivity relief as well as improved gum health.
Got a couple of channels here. This is just a regular antenna. I got one of those.
It usually comes with a bottle of good whiskey, but that's going to look too familiar on you.
Look at that.
Something else she likes?
All right. So, the battery comes out. I mean, the thing is hooked up here. As you see, goes straight on there. We just made that. Boom. Comes here. See the cable? Runs in there. And this goes to my TV antenna I got over there. Don't look over there. That's a mess. And all I got is a little bunny rabbit. Not a little bunny rabbit, but it's pretty big. That's all I got right there. Is that bunny rabbit right there. And that's aimed to Sacramento or Reno, that area. So yeah, it works. So yeah, it's fine. Okay, it's draining a lot. Look at this. It was 12.3, now it's 12.2. So it does use a lot of juice, but we could make a bigger one. So we got 80 amps, 12 volts, 950 watts, 960 watts. So this TV is 1 amp. Jesus, 1 amp. I could run that forever. How many watts? I'd say about 60, 70 watts. This thing is, right? Because you got 1.5. I don't know what it'll be. So yeah, probably like 70, 80 watts it uses, 60, 70 watts, something like that. I'm just guessing, I'm throwing a number out there. So I could essentially run this on this for about 8 hours, 6 hours before it kills it, right? Because remember, I only could use like 80% of that, 80, 90% of that. Oh no, I could use the whole 100, so I could run that for 10 hours if it was 90 watts, you know, because you're going to lose some in between here. So that's great, that's good to know. I can run the TV now. But this is for my fridge. All right, let's unplug this. It works. We made a 12-volt battery, but we're gonna plug this back into the regular generator. And the generator runs out that way. We're gonna put the BMS now, the battery management system, and this takes a long time for it to charge. So we're gonna have a negative feed out. That's supposed to go somewhere, and then this one goes all the way down here. Oh shit! And then this one. I don't know how this goes, guys. So it's supposed to be your first positive, alright, positive, alright, boom, this one's gonna go here, boom, and this is gonna go to the back of the negative. So this one has to come all the way down here, and then the rest goes, and the rest will go, one goes, this one goes. All right, let's put that together. So it reads the whole system, right? It wants to read across the system is what it wants to do. And then and the reason I like this one, they were 20 bucks each. They were a little pricey, so I spent 100 bucks or 80 bucks plus the this BMS was like $7. So I spent $100 to get an 80 amp battery for my fridge, so I could put the fridge on there, and then my fridge will run. So that's your negative, and we want, this is negative. We're just doing the BMS right now. Then so it reads it correctly. That's good. The next following one for the negative should be the top out of the positive, right? So now it reads the whole thing as a battery system, so it knows it's 12 volts. And this BMS is a 3S 100 amp BMS. Let me turn it this way, make life easier. And they can lock in there. I just soldered these wires onto these clips, you know. It's a little tack there. So I had a ring, because all it was bare wires, so. And, that's annoying. Okay, so now it's reading 12 volts. It knows there's 12 volts. So now it's gonna ask the legs, right? So in this number 2 has to go to the next one, the next positive, right? So the next positive, yep, it's on this side. The next positive is on this side. It'll be right here. Remember that silver is positive, copper is negative. So that, ring there, here. And you saw me short this out, so it shouldn't work anymore. But hey, it's working. Right? Maybe kind of scared that it's gonna break that wire. As long as it crushes it, that's all that matters. There you go. And that big knob is not gonna let it. All right, perfect. It's not gonna let it spin. Yeah. All right. So we got a nice tight seal there. And then this one has to go to the positive all the way on the bottom down there. Yeah, okay. So let me spin this around. And the battery management system, the BMS, from my understanding, all it does is it charges it as like a trickle charge. It doesn't let it charges each cell. Each one of these are cell, even though there's 4 cells in each cell, which is more of a breakdown, at a slower rate so they don't overcharge, and it doesn't let it overcharge, right? So keep it from overcharging. Kind of rough, this guy. So that's the whole point of the BMS. Oh man, come on, what's going on here? There we go. There we go. Keep that up. Okay, boom. All right. So our BMS is hooked up. All right. I got a wire there, and I think I need this one down here too. I didn't realize that. I think I need that one down there too. And this goes into the negative. I don't know where that goes, but I think that one has to go down there too. And that kind of feeds this and that one. I think that's how it works. I actually don't know, guys. I watched those two guys, Jehu and Posa, do their videos, and I watched several of them. I got an idea of it, you know, and that's all I got, the gist of it, and that's all I'm running on. So if I get the gist of it, and I could do it. You see me turn on the TV, and I was running the TV. We're fine. But this is specifically for my fridge, so when I go camping and stuff like that. Oh, all right. So now here and there, I should get 12 volts. So we got a trusty Harbor Freight multimeter there. So we got positive here. Boom, positive here, and then negative here off of this leg, off the BMS, and we got 9.6. It's only allowing 9.6 volts out. It's not letting it completely charge, but if I go to negative down here, I'll get 12.3. So the BMS is going to control it from being overcharged or undercharged. So it's saying right now, hey, there's only 9.6 volts in here. Add more voltage. So it will probably overcharge it. Now that I think about it. Because there's 12.3 volts here. Now, see, this is the thing that confuses me. I don't know enough about this for anything. It's 9.5 is losing 2.5 volts, saying that's not charged. So if this was plugged into a power source with this on that end and had a power source here on this end, it wouldn't charge. It wouldn't take. It would die. Because the BMS is saying it's all undercharged. It doesn't have enough power. So I still don't know nothing about these BMSs. But we are going to wrap this up and call it a day. This is how it's working. This is how it's staying. I'll leave this leg out. Let me wrap this. You know what? I should put I got screws here. See if I can put screws here. I don't think I got long enough screws here. No, I don't got long enough screws here. Maybe in this one's a little longer. Yeah, these look a little longer. I just need 1, 2, 3, 4. I need 8. Is this longer? This is the longest ones here. Boom, we got something, huh? We got something, let's see what happens. We got nothing. These things are just... Oh, wait a minute. That's something, buddy. You know, tape works just fine. I'll tape this up. This tape right here is called Captain's Tape with a K. And it's just like some high, intense, high heat resistant tape. So it won't let nothing overheat or anything like that. So now we got our numbers. We know we got 12 volts, 80 amps, comes out to 960 watts. We got a 960 watt battery that we made. So if you want to look up generators that are 960 watts, and you add this to one solar panel, you're pretty much good. All right. Let's cross it that way, and let's go in between these two right here. All right. All right. Yep, that's good. Huh, my kitchen knife. Those are seeds for watermelons and cantaloupe. So that's it. We got our battery for our fridge. Now, we got the information there, which is great. I'll go around 3 times, and that should hold it nice and tight. It's like if you put tape on yourself 3 times, it'll be get nice and tight there 3 times. So I'm good here. Let's tape that up there, huh? Kind of skeptical here. I don't know. I don't know how to tape this up. But in either case, I'm not gonna let. You know what? I need to figure that out first. I'm not gonna let. I'm not gonna take the voltage from here. I'm going straight to this. Going straight to it, and I'm gonna let. There we go. No, I'm not going all the way around that thing. I just want to kind of cover the letters over here too, because I'm not going to remember the numbers or anything like that. So I'll leave this open just in case I want to disconnect that. There we go. Kind of a waste of tape right now looking at it. Whatever. So there's that. Now we got a battery. Yeah, we're good. Doesn't look that great, but it's functional. We got 12 volts. It's heavy, but it's gonna go in our battery box, and that's going in there. And I took this out of my Honda, so this is gonna be. We're gonna make a power wall out of this, out of all the different batteries. So it's gonna be like a 12 volt section and 24 volt section. All right. Gotta figure something else out. I gotta figure out the solar panel, right? I wanna hook up. Okay, we got our pack all wrapped up. We know we got 900 watts. We'll figure out the BMS later, but we know it's a battery management system, and it charges it. It keeps it from overcharging. I don't have to worry about this flip-flopping. It's a little heavy, but I think it was well worth it. So now my fridge is gonna come off of these old batteries here. All right, so these batteries here, this is it. It's connected to the solar panel, which is on the roof, and it's dumping in energy there. But these things, they're old. They're from my old cars, and they just gave out, and I just started putting them together. And I've been getting by for the winter with this, with my fridge. You know, I have to run the generator sometimes to charge it back up, but and I've only been running one solar panel. I'm running one solar panel off of here, which is the one, which is this wire, right? It goes all the way down there. You see, it goes all the way down there, and I got it hooked up here and there. These are the 2 wires coming out here into the charge control, then out. Because it's only one solar panel, I use this old wiring that a friend of mine gave me. Oh, I think I got it off of that thing, I'm not sure. So I got this one solar panel right here. This is 320 watts, or 255 watts, I'm sorry, 255 watts. And then I brought a bunch of connectors. I brought a bunch of connectors and I connected them. Alright, so boom, boom. And this is regular house wire, but this could hold 30 amps. You know, it's a 30 amps, but this is only dumping out, you know, 30 volts at probably 9 amps, 12 amps, you know, so we'll let it go. So now one solar panel will run my fridge with that one battery. Where's the ball? Better get the ball. The one solar panel and the battery will run my fridge. So it's coming in, it's bringing in voltage, and it's reading 12.5 off of all these batteries. And I'm charging these batteries off of this quick charger for with the generator that's running right now. So I keep charging them because they're not meant to be drained up and down, and that's what the fridge and my TV and everything's doing. But I've been getting by with it. It lasted me through the winter, and these are used batteries. Let's take these off, huh? Let's take these off. Let's get an adjustable. Is there an adjustable, a wrench or something? There we go. That would work. I'd rather have an adjustable, but this will do. Alright, so negative off. So that's that. That's off. Put this on. These are the jumpers. And this is a parallel system. Right here, this is a disgusting parallel system. So it's negative, 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 positive, positive, positive. So I'm multiplying the amperage here because there's no amperage in these things. They have maybe 70 amps. You only can use half of that. So there's only 35 amps in each one. And they're depleted. They're old used batteries. So I'm only getting probably half of that, right? Because these batteries are already dead. They came out of my vehicle. So there's no this is another one I got from battery hookup. This is for the lights. And honestly, I've been lazy because I've been getting by with it, and it's been okay. It wasn't that difficult to actually build a battery. I didn't have to build one because I had these old junk batteries for my car, and I made it run. And this is an example of 12 volts in parallel, you know. So you just connect negative, 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 positive, positive. So the voltage stays the same, which is 12 volts, and the amps stay the same. So it's still gonna have, no, the amps multiply. So I'm adding this amp plus this amp plus this amp. So if this has 35 amps, then 35 amps, 35 amps, you got 105 amps. And if it's half of the life, I only get 50 amps. So after, you know, it's very depleted. These things are weak. I only get like a couple of hours out of it, but it runs the fridge, and that was the most important part, keeping my fridge running. So, see, it's going crazy now. It's like, where am I dumping all this? It goes 24 volts, 18 volts. It doesn't know where to dump it. So we're going to dump it in here. I like quick disconnects. I don't like a permanent system, because if this is a battery protection system, like it's saying it's connected to a battery, there's nothing there. That's weird, huh? I think this thing's shorted out. I don't know. So our bottom negative, which is down here, and our top positive, which is up here. So let's do that. Let's take this off. And it shouldn't be reading anything there. It should be like a blank there. I don't know. It's going crazy. Where's the screwdriver? Oh, oof, oh. Here's the screwdriver. Freaking nails, man. Okay. Oh, damn. I got crap everywhere. Coming out of the winter, and I know what a bear feels like. Okay, this is our negative. I'm gonna put our negative down here. There's a lot of shit hooked up to this negative. There we go. Those act like a washer. Oh, very dangerous. Right close next to our positive. Okay, and then the positive out, up on our top of our positive. I come up with a better system than this because this kind of sucks, huh? Okay. There we go. So now it's reading 12.1. Huh. Oh. So that's reading 12.1. It's in our trusty Harbor Freight meter here. It's reading 12.1. Negative and our positive here. 12.3. Okay, I can believe that. I don't know why such the drop though. And it was 12.5. Whatever. As long as it's feeding it. As long as we're getting it. As long as we're getting power, right? Alright, so fridge is running 12.2. Yeah, okay, so whatever. It's reading the same number. 39 degrees. Everything's nice and cold in there. Yeah, everything's good. Yeah, I'm golden. You can see there's ice condensation there. It's ice. So it works great. Yeah. So Apple Cool, I got it from Apple Cool, and battery hookup is powering it up. The last 3-4 days with that battery system. We'll put it through a test, and I'll put that video up along with this video. And that's it, guys. Like, share, subscribe. All this stuff is gonna get picked up, and we'll keep going. Let's keep moving from here. Now that it's nice and warm, we could do some stuff. It feels better that the weather's giving up. You know, the Mother Nature's giving me a break, allowing me to breathe like a buddy. He's just dead tired. He's just like, I don't want to do anything. It's giving us a little bit of a break, and the winter's over, so now I could build and prepare for next year. And because honestly, I won't be able. I'm not capable of dealing with that cold again that I just dealt with. I'll just walk away from everything. Just walk away, man. I can't deal with it. Yeah. So batteries are up. One battery's up for the refrigerator. We're gonna work on an AC one. And then for the TV and the PlayStation and all the other devices. And then we should be good. Little by little, slowly but surely. But if I could do it very simply, you guys could do it too. Go to battery hookup. You guys could put this together. You saw me put a 12-volt battery together without a problem. It wasn't difficult. I'm not a rocket scientist or anything like that. So it's not difficult. You can build your own battery, and as long as you play with the numbers and understand it a little bit, have a little bit of a knowing of Ohm's law, then you don't have to memorize it. Just understand it. Basic stuff. You can build a battery like I did and power stuff up in the middle of nowhere. Now the battery should last me 20 years. maybe 10 or 15 years. Where the car batteries only last 5 years. and they're not meant to drain. And if you get one of those deep cycle batteries, they only give you 10 years, you know. This right here is going to outlast that, and is a quarter of the price. You get one of those deep cycle batteries that has 100 amps or 80 amps. You're looking at like $1.50 per amp or something like that. So you're probably looking at 120 bucks, 140 bucks. So I paid about the same. Okay, I paid about 100 bucks, but I'm getting 5 more years out of it because these batteries are meant to dump heavy loads, and it's not gonna. That refrigerator is gonna draw 5 amps an hour or something like that, and not even. It's like 3.5, but I'm putting on the high end for 5, so I'm good. I'm good. All right, guys. Like, share, subscribe. Look forward to you guys doing the same thing. Go to Battery Hookup. They actually have a hookup. Watch out. It's very addictive. I got those batteries, and I got a couple more batteries. And I just wind up buying batteries just to see what they are. Like, I brought these little ones, and I was like, oh, this is cool. I'll make a light system out of this. And this has its own BMS system, and I could just hook this right up to the BMS is right on top there. You see all the wires in here hooked up, and I could read the information off of there. We'll get into that later. Like, share, subscribe. I'm sorry, guys, I'm going to rant, but I'm very excited. I actually got the TV to power up and go through some channels, and the antenna worked too. The antenna was, you guys didn't need to see build that. That's it, man. Go to Battery Hookup, build some batteries, you know, come up with some ideas. I'm about to do some EVs. I got a couple little small EVs going on, so I got to buy batteries for that. Right now, let's work on the house and get all that lit up and in the backyard lights and stuff like that. So now you know you can power up a TV if you want to go camping with $100 and not even worry about it. And be secure. If something fails, you know how to fix it because you put it together. And that's the biggest thing. Being able to repair something and not be dependent on somebody. That's what we like here at Lawless Ranch, right? I'm Al Wrench, signing off with some backyard engineering. There you go, guys. Talk to you later. Peace. Buddy.